Hello guys, welcome to Pepcoding, and now we are going to discuss the next question, that is construct a binary tree from the pre-order and in-order traversal. So in this question we have been given the pre-order traversal and in-order traversal. Okay, so we have been given the two arrays of pre-order and in-order traversal, and by using these two arrays we have to construct a binary tree. Okay, so let's see how can we do this. So we have been given these two things. First array is the pre-order traversal and the second array is the in-order traversal. Okay, so by using these two array we have to construct this tree. Okay, so let's see how can we do this. So when we do the pre-order traversal, that is, so this is the pre-order traversal. First when we move, so first we found the root node. Okay, then we found 1 3 7 8, then again we move toward this side, then this side, and then this side. Okay, so first we traverse the left hand side, all the node in the left hand side, then what we do, then we traverse all the node in the right hand side. Okay, so in pre-order traversal we have found two things. In pre-order traversal we have found two things, that first node is root node. Okay, and what is the second thing which we have analyzed it? Like first we got the left side, left node, and then we got the right node, all the right node. Okay, so first we got all these node, and then we got all these node. Okay, so we have seen the two things in pre-order traversal. Now let's move towards the in-order traversal. Okay, so let me write all the thing. This is the root node. We already know the root node now. Okay, with the help of pre-order traversal we know the root node. Okay, so we have to take the help of these two arrays and we have to construct the tree. Okay, so let's see in in-order traversal. So let's see. So when we move toward when we do the traversal of in-order, so first we got the 7. Okay, first we got 7, then we found 3, then we got 8, then again we got 1, then we got 9, then we got 4, then we got 8, and then we got 0. Okay, so in case of in-order traversal, first we got all the left hand side nodes. Okay, all the child node of left hand side of the root. Okay, so first we got left side nodes. Okay, all the left side node, then we got root. First we got left hand side, then we got root, then we got all the right hand side nodes. See, first we got 11, then 5, then 2, then 6, and then it will backtrack. Okay, then all right side nodes. So in order we have to take care of these things. Okay, so I am going to take the help of these things. Okay, so what I will do is, let me just erase all these. Okay, now I know the root element. So what I will do is, I will traverse to the root element. So I will directly move towards the root element. Okay, somehow I will find out the root element. Okay, because I know the root element is 0. Okay, then I directly jump toward the root element. So in order, I have found the index of the root element. Okay, then what I will do is, now in this case I already know, like these elements are the left hand side. Okay, these elements will come to the left side of the root node. Suppose this is the root node, so all these elements will come to the left hand side. That is 7 3 8 1 9 4 10. So all these elements will come to the left hand side to the root node. And what is the second thing? all these elements which are right side to the root node will come to the right hand side in the tree. Okay, so 5, 11, 2, 6, all these elements are the right hand side. So let's see this, let's match this. So 2 is here, 5 is here, 6 is here, 11 is here, and all the elements which are in this side, left hand side, are there only. Okay, so we have find out this. Now let's move toward the pre-order. Okay, so let's move to the pre-order. Let me first control Z it. Okay, so again, one more thing what I will say is, I have discussed in pre-order traversal, first root node come, then all the element toward the left side, all left element come, then all the right node come, all right node come. Okay, this we have discussed. So first what I'm going to find out, I'm going to find out the root node in inorder. So for this, how we are going to find out? So let me calculate it here. Okay, so find root in inorder. So let me take index. So I'm going to find out the index of root in inorder. Let me take idx, that will equal to the 6. Okay, so how I am going to find out 6 here? So first I will initialize idx with 0. Then what I will do is, I am going to traverse it. Okay, so I am going to traverse in inorder array up to when? Up to we found the root element. Okay, so let me write the code. See, I'm talking about this thing. So I'm going to traverse it while in order in of idx is not equal to pre of. What is the index? That is starting. Let me introduce with psi, that is pre-starting index. Okay, because pre-starting index is the root index. Okay, if this condition holds true, that means it is not equal. So what I will do, I will just simply increase the value of idx, and in the end what is going to happen, first idx will point to this. Okay, then it is not equal to the root element. Then what I will do, what I will do is, I'm going to increase the value of idx. See, now again it is not equal, then again I will do idx plus plus, again I will do I plus plus, again I will do I plus plus. It is not equal to 0, again it is not equal to 0, again it is not equal to 0, again it is not equal to 0. Now array of in of idx is equal to the pre of psi. That means now in this index we find out the our idx value. So we have to just what will happen, while will be terminated. Okay, and we can find out the value of idx, that is 7. Okay, so by this way we have find out the value of idx. So idx will become 7. Okay, now what will be the value of total element? So the second thing which we are going to find out is the total number of element. So this is idx, and all these elements are see, all these elements are the left side element, and all these elements are the right side element. Okay, so these elements are these, let me do this, these elements are this. Okay, so we have segregated the elements. Okay, so what is the second thing? How can we find out the left side nodes in pre-order array? So what I will do is, I'm going to find out one more thing, that is total number of element. Okay, with the help of total number of element TELE. Let me write the name with TELE. Total number of element. Okay. So I'm going to find out the total number of element. And what simply I will do is I will find out the total number of element that is equal to 1, 2, 3, 4, 5, 6, 7. Okay, so I will just increment the 7 here. See, suppose I got 7 here. Okay, because there are 7 number of element. So if we got 7 here, so what I will do, I will just increment the 7 value here, like 1, again plus 1, 3, 4, 5, 6, 7. So if I will increase the value in, this is the value of PSI. I have just given a variable name that is pre-starting index. Okay, and if I will increase the value of TELE, that will equal to the, that will point to this element. Now all these element are the element which are pointing towards these element in case of pre-array. Okay, so let's I will do it further. Okay, so let me just control Z and I will do once again. So first I'm going to find out the total number of elements. So how can we find out the total number of element? The total number of element can be find out by, I will just decrease the value. So let me take 4 pointer. Okay, so let me take the 4 pointer. What is the first pointer? The first pointer is pre-starting index. The second pointer is in starting index. Okay, and then pre-ending index and in ending index. So I am going to take these 4 variables here. Okay, so now in starting, what is the pre-starting index? In starting, the pre-starting index will equal to the 0, comma, what is pre-ending index? That is 11, and what is ISI? That is in starting index, that is equal to 0. What is in starting? In ending index, that is 11. So in starting, we will find these 4 variables. Okay, pre-starting index, that will point to the first index, and in and pre-ending index, that will point to the last, and in starting, that will point to the first in array, and then IEI, that is in ending index, that will point to this. Okay, so I'm going to take the help of these 4 variables. So let me store these variables also. So actually now it will work. Okay, so let me store it here. So these are the 4 variables. Okay, so I'm going to find out the total number of element. And what is the value of total number of element? I will just decrease with 0, like IDX minus 0, that is 7 minus 0, that is 7. That will be the total number of element. Okay, you just simply have to do the B minus A if we want to exclude this one. Okay, so like suppose if you want to find the total number of element, what you do? Just simply do the B minus A. So this will exclude this and include this one. Okay, so we already know this formula. So what I will do, I'm going to IDX minus, and what is the starting index? ISI. Okay, so we are just writing all these values. Then what I will do, I will connect all these dots. Okay, so I am writing all the formula here. Then when I will do coding, then I'm going to connect all these dots. I will also show you the formula which we have written. So that's why I'm storing it. Okay, so now we have segregated it. So now we know, like up to this is our ISI, and we already know like how we can jump toward this. I'm going to, what is the starting index of this? So I'm going to find out these elements. So I need to find out these elements. I have to divide these elements. Then I'm going to use the faith call. So let me introduce for the faith call, like how I'm going to call these. Okay, so let me shift it here. Okay. So what I will do is I have find out this root element. Now this root, we will create this root element here. Okay, we can easily find out the root element. Okay, but we just simply see the first index of preorder. You can easily find out the root element. Then what will happen? This root element give the two calls. Okay, the first one, the root element will say, so up from 0 to 6 element, go and create your binary tree. And after creating your binary tree, just attach to my left. Okay, so it will order these elements to go and create their binary tree and attach towards the left of his root node. Okay, so 0 is going to order all these elements. See, like this. 0 will say 7, 3, 8, 1, 9, 4, 10. All these elements go and create a binary tree and attach to my left hand side. Okay, and it will also say order to these elements also, that 11, 5, 2, 6 go and create your binary tree and attach to my right. Actually, this is the faith call. Okay, I'm talking about the faith call. This is the faith call. Okay, and in the starting we are receiving these four indexes. What are these indexes? We have already talked about. The first one is the PSI, pre-starting index. What is the second one? Second one is pre-ending index. Okay, 0 to 11. 0 to 11. Okay, and what is the starting of this third one? In starting index. And what is the second one? In ending index. Okay, so we will receive these argument, and what will happen, what is going to happen, we can find out the root element from these array. Okay, so in this big array, we know the first element is the root element. Okay, now we have to find out all these four vertices, all these all these point in this call also and in this call also, and how we can find this. Okay, so we need to figure out this. So this is really important. Okay, so let me find out all these. So this is the left call. Okay, so let me separate this here, and it is the left side. So first what I'm going to do is I'm going to find out the PSI for left. Okay, I'm going to find out the PSI, PEI, and ISI and IEI. So I'm going to find out the four vertices for left hand side as well as for right hand side. So what is the value of PSI? PSI will start from, actually this was the earlier PSI. It will increment by 1. So now what is the left hand side? See, this is the array. So let me write it clearly. So let me segregate the array actually. Okay, so let me segregate the array. So this is our array. Three, 4, 5, 6, 7. 4, 5, 6, 7. Okay, so 1, 3, 7, 8, 4, 9, 10. Okay, so these elements will go and create their BST, and in case of InOrder also 7, 3, 8, 1, 9, 4, 10. Okay, now let me divide for this side also. So there are only 4 elements, 3, 4. Now these are the 2, 5, 11, 6, 11, 5, 2, 6. Let me write the index also, 8 and 11 and 1 and 7. So we have to find these. Okay, so this is what we are doing. We have to find this index, this. So then we are going to pass like this. Okay, so let's see it. So what is the value of PSI? PSI is simply it is equal to the PSI plus 1. Okay, so what was PSI? 0 plus 1. So it will equal to the, let me write with this, PSI plus 1. Okay, so what will the value of PSI? PSY 0, 0 plus 1 is equal to 1. So we have find out this. So this is this is in. Okay, so we have find out the PSI. Now what is the value of PEI? PEI will equal to the 7. That is equal to 0 plus total number of element. That is PSI. I will just request you to please pause this video and just think about all these coordinate, all these points. Okay, then just cross check it. Okay, so now I'm going to write all these points. So PEI will become PSI. This was our PSI, and I'm going to add with total number of element. That will be the 7. What were total number of element? See, this was the total number of element. TELE. So now we have find out the PEI. Okay, now let's see about LSI. What is LSI? Is the left starting index. That will be equal to the LSI only, left starting index, and up to how much it is going to end? It is going to end IDX minus 1. Okay, so this is the ending index of this. Okay, so let's write the same thing for this side also. Okay, so first I'm going to write the index. So what is the PSI? PSI will become PSI plus 1, that is 0 plus 1, 1, comma, PEI will become 0 plus TELE, that is 7. So it will become 7. Then I'm going to write ISI. ISI will become is equal to ISI only. Okay, so that is equal to 0, comma, IEI. Now we are going to find IEI, and what is the value of IDX? Let me see it here. That is 7. Okay, so 7 minus 1, that is 6. Okay, so this is what we are going to find. Okay, so if we can find out the index of ISI, you can see that. You can see it here. The index are 0. It is starting from 0 to 6. And they are starting from 1 to 7. Okay, so don't confuse in it. Actually, this is somewhat shifted toward the left. Okay, so they are starting from 0 to 6, and it is starting from 1 to 7. Okay, so this is what we have to write. Now let's do from same thing towards the right hand side. So now I'm going to write the let me shift it here only. Now I'm going to write the PSI and PEI, and then ISI and IEI. Now again I'm going to write all these 4 coordinates. Okay, so what will be the value of PSI? PSI will be the, see, PSI will become the IDX plus 1 in case of ISI. First I'm going to write these 2 values because these are very easy. Okay, so IDX plus 1, and what is the IEI? IEI will become the same as IEI. Okay, so this we can easily understand. Okay, now we have to find out this. Okay, so how you can find out this? It is actually the 7 plus 1, and we have already find out this value. Where we have find out? We have already find out by PEI. Okay, so first what I'm going to do, I'm going to start from here. Okay, so I'm going to first jump it from here, then I'm going to take one step. So it will start from here. So PSI plus 1, then plus total number of element, then plus 1. So this is how we will reach in this point. Okay, so I will take psi plus 1, then plus TELE, total number of elements, then plus 1. So this is how step by step we are going to reaching in this point. So what is the value of this point? This is psi plus 1 plus, actually this is psi plus TLE is actually the 7. If we increase 7 here, so it will directly jump. So actually I have done one step wrong, so let me correct this. Okay, so we are having total number of element is 7, TELE is equal to 7. So what I'm going to do is I'm going to jump from starting point to 7, directly 7, that is 0 plus 7. Okay, psi plus total number of element. I'm going to jump directly here. Then what I'm going to do, then I'm going to take the one step. Okay, so what will be the value? Psi plus total number of element, then I'm going to increase by 1. Okay, and what is the value of PEI? PI is actually the PEI will actually, it will equal to the PEI only because it is 11. Okay, it will always be the ending point. So like this way we can find out all the 4 coordinates. So this is the important part in this question. Okay, so how we can find out the question? Again, let me repeat the same thing soon. Okay, so what I will do is, so again, now I have to again use the 2 calls. So first what I'm going to do, I'm going to use the calls. Okay, so what will be our root element in this position? So in this position our root element will be the 1, that is the first index. Okay, so now idx will equal to here. Okay, and total number of element, so idx, let me write the value of idx, that is 0 1 2 3. Total number of element will equal to the 1 2 3, that is 0 minus 3, 0 plus 3, sorry, b minus a, b is 3 minus 0, that is equal to 3. So these are the values. Okay, so what will be the value of these calls? So now we already know, like we have placed root node. Now what is going to happen? We have to separate this into 2 parts. Like one will give the order to 738 and say go and come in the form of tree and attach to my left hand side. Okay, 738. Okay, and what is 378? These are the 1 plus total number of element. See, this is, we are going to find out the PEI, that is pre ending index. Okay, so again it is going to give the order to these elements, and toward the right side it is giving order the 9 4 and 10. Okay, so this is how again they will choose the root element. So again one by one all the root element will come into the position, and this is how we are going to do this question. So now I'm moving towards the coding part, and we will see one by one how we are going to code this question. Okay, so let's move it. So now I'm going to code this in Java. Okay, so let me do this full screen and let's code it. So we have to implement here. Okay, so first what I'm going to do is I'm going to store n, that is preorder dot length. Okay, so first I'm going to store the length, and then I'm creating one separate method of name create tree. Okay, so create tree, and what we have to find, what we have to pass in the starting. So let me show you. Let me just small it. Now it is a good visible. So first what we have to pass it, we have to pass the psi, pei, isi, iei. Okay, so all these 4 values we have to pass, and we also have to pass these 2 arrays. Okay, so let's do this. Okay, so we are going to pass the preorder, then psi, that is pre-starting index and PEI and in order and ASI and IEI. So we have to pass these values. So in the starting, what we have passed? We have passed the 0, that is the first index, and the last index. Okay. So again, I'm going to change this. And what is the last index? That is n minus 1. Same for ISI, that is 0 and n minus 1. So we have done this. So what we have to do? We have to just create our one method, that is public static pre-node, and create tree, and in the argument what I'm going to receive it, I'm going to receive one preorder array, then int psi, int pei, and the second one is inorder array, int inorder comma int isi, int iei. Okay, so this is what we have received it. Okay, so now let's see what is the first step which we have to do. So now we have to first find the root node in the in order. Okay, and we already know what is our root node. Root node is the starting PSI index of preorder array. Okay, so preorder PSI is the root node. Okay, so what we have to do, we have to start the IDX from 0. It is actually not 0. In this we have to start with the this ISI value, ISI, because we have to start our IDX from here. Okay, that is the starting index of in order array. Okay, and then we are going to traverse it. So let's do this. So first I'm going to take one variable, that is int IDX, starting with ISI in starting index, and I'm going to use the while loop, and in order of IDX is not equal to preorder of PSI, that is our root element. Then what we have to do, we have to increment the IDX. Okay, so one by one we are going to increment the IDX, and when we will get this, so then in IDX will be maintained, that IDX will be the index of root node in the in order array. Okay, then what we have to do, then we have to find the total number of element, and the total number of element is IDX minus ISI. So let's find this. Int TELE, total number of element, that is equal to the IDX minus IEI, that is actually the ISI, sorry, B minus A. Okay, then we have find this. Now what we are going to do, now we are going to create the node. Okay, so we have completed this part. Now we have to create the node. Okay, so let's create the root node. Pre-node root equal to new tree node, and what is the value of tree node? Preorder of PSI. Okay, so we have created the root node. So each and every time we are going to create the root node. And now what we have to do? Now from the root node we have to give these two calls. Okay, so first I'm going to give the left call, that will be attached to the root of left, and then we are going to give the right call, and we will attach to the root of right. Okay, so we are just segregating these two things, and we also have to pass these. Okay, so we have already calculated these. Okay, so don't worry about it. So we have already calculated these things, so we are going to use these things only. Okay, so let me do this. Okay, so let's give the left call first. So let me copy this, and this is for the left call. Okay, so what we have to do is we have to pass the preorder, PSI, PEI, in order, and we are also going to change these values. Okay, PSI and IEI. Okay, so what we have to store in PSI? So this is for left. So PSI is actually becoming the PSI plus 1. Okay, and PEI will become PSI plus T total number of element. PSI will become PSI plus 1 and PEI will become PSI plus TELE. We have already discussed like how we are getting these values. Okay, and ISI will become equal to ISI and IDX minus 1. ISI and IDX minus. Okay, and then what we have to do? We have to attach to the root of left. Root dot left. Okay, so just I'm going to copy same thing. And now what will be the case for the right side? So this is for the right. So now the PSI will become PSI plus total number of element plus 1. Just going to TELE. Okay, and what is the value of PEI? PI will become PI only. So let me change PEI, PEI, and what is ISI? ISI is equal to the IDX plus 1 and IEI will become same. And it will remain the same, IEI. Okay, so now simply we have to return the root. Okay, so we have attached these two things. Now our last step is remaining. Okay, that is base condition. So what will be our base case? Base case is actually simple. When our starting index is greater than ending index. Okay, when PSI is greater than PEI. And what we have to return? We have to return the null because there are no element in the array. Okay, so now I think I have done this. So let me run this and check for the compile time errors. So it is giving me the wrong answer. Let me check this. Let me check the code. So actually I have not updated this value. Okay, so let me run it now. So let me check it now. So it is accepted. So let me check for all the test cases and see whether, and all the test cases are running absolutely fine. So thank you guys for watching this video and we'll meet in the next video.